Determine the equation of a line that passes through point A with coordinates 3, 0 and initially forms a 30-degree angle with the positive x-axis. If the line undergoes a clockwise rotation of 15 degrees, find the equation in its new position. So let us begin. First, what we'll do, we'll consider the coordinate axis. So here we have the axis, the coordinate axis. We begin by first considering the point A on the x-axis, and this particular point A has the coordinates 3, 0. Now, let's do one thing. We are going to pass a line through the point A, and also it's going to make an angle 30 degree with the positive direction of x-axis. So here we have the line which makes an angle 30 degree with the positive direction of x-axis. Now what we'll do, we will rotate this particular line by an angle of 15 degree in the clockwise fashion. Now clearly the line has rotated clockwise by an angle of 15 degree. So if it is rotated clockwise by 15 degree, here from the figure itself we can say that the angle that it makes with the positive direction of x-axis is all going to be 15 degree. Now to find out the equation of the rotated line, we need two information. One is the slope of the line and one point which lies on the line. Now clearly we have a point A through which the line passes. The next goal will be to find out the slope of the line. The reason behind this is we are going to use the slope-intercept form of a line. So let's quickly recap what's the slope-intercept form of a line. The slope-intercept form tells us that if we have a point, let's say the coordinates are x1, y1, through which a particular line passes, and we also know the slope of the line, then the equation of the line will be given by y minus y1 equals to the slope times x minus x1. Now in our case, we have the point A 3, 0, so that corresponds to the point x1, y1. Now our goal will be to determine the slope of that line. So the slope is very simple. The slope will be simply defined as tangent of the angle that the line makes with the positive x-axis, which is 15 degree. However, we don't have any standard value for tangent 15 degree, but what we can do, we can rewrite 15 degree as 45 degree minus 30 degree. Now what we get is a tangent of a compound angle, which is the difference of two angles. So here what we'll do, we'll use the trigonometric identity. We know, so let me note that down. We know that if we have tangent of A minus B, so that's simply expressed as the ratio of tangent of A minus tangent of B to that of 1 plus tangent of A times tangent of B. So in our case, we have A, which is 45 degree, and B will be 30 degree. So that means this expression will now become tangent of 45 degrees minus tangent of 30 degrees whole divided by 1 plus tangent of 45 degrees multiplied to tangent of 30 degrees. Now we know the values of tangent 45 degrees and tangent 30 degrees. The tangent 45 degrees, that is a standard value equals to 1. Tangent of 30 degrees has a standard value of 1 over square root of 3. So let's substitute these values. We get 1 minus 1 over square root of 3 divided by 1 plus, we have 1 times 1 over square root of 3, or simply 1 over square root of 3. So this is going to give us square root of 3 minus 1 divided by square root of 3 plus 1. So let's do one thing. Let's rationalize the denominator. To rationalize the denominator, all we have to do is take the conjugate of the denominator. So that will be square root of 3 minus 1. And we're going to multiply with that conjugate to both the numerator as well as the denominator. Fine. So now what we'll do, we'll simplify this. So let's do the simplification. So square root of 3 minus 1 multiplied to square root of 3 minus 1. So that will be simply square root of 3 minus 1 whole squared divided by, now here we have the product of square root of 3 plus 1 and square root of 3 minus 1. So that's nothing but the square of differences, square root of 3 whole squared minus 1 squared. So let's expand them, each of them. So we get square root of 3 whole squared minus 2 times square root of 3 times 1 plus 1 squared divided by square root of 3 squared, that's 3. So we have 3 minus 1. That will be equals to 3 minus 2 times square root of 3 plus 1 divided by 2, which gives us 4 minus 2 times square root of 3 divided by 2. Or simply put, we have 2 minus square root of 3. So this is going to be the slope of the line. So now we have the slope. We also have the point through which the line passes. So that's 3, 0. Now we are ready to find out the equation of the line. So our equation will be y minus y1 equals to m times x minus x1. So that's the slope-intercept form. So here 3, 0. So that corresponds to x1, y1, which means that the value of x1 equals to 3. Value of y1, that's simply 0. Substitute this value. So we have y minus 0 equals to the slope 2 minus square root of 3 multiplied to x minus 3. Okay, let's further simplify it. We get y equals to, so we have 2 times x minus 3. So that gives us 2x minus 6. Then we have negative square root of 3 times x. We have negative square root of 3x plus 3 times square root of 3. So rearranging the terms, we're going to get square root of 3. So we're transposing negative square root of 3x to the left hand side as well as 2x. So we have square root of 3 minus 2 times x plus y. And we will transpose negative 6 and plus 3 square root of 3 to the left hand side as well to get positive 6 minus 3 times square root of 3 equals to 0. And this is going to be the required equation of the line, which was initially making an angle of 30 degree with the positive x-axis, and then it was rotated by an angle of 15 degree and passes through the point 3, 0.